The mosquito-borne disease malaria infects more than 200 million people around the world each year and results in nearly 800,000 deaths. And although the disease is no longer endemic in Australia, scientists in Brisbane and the Gold Coast are at the forefront of malarial research. While some are concentrating their efforts on producing drugs to treat the infectious disease, others are involved in clinical trials for a possible vaccine. Lynn Keep reports.
In a Brisbane laboratory, robots are doing the work of hundreds. The accelerated approach will hopefully provide a breakthrough in treating one of the world's deadliest diseases, malaria.
If you look at the diseases which rob people of most of their life, malaria is probably near the top of the list.
This work at Griffith University is Queensland's contribution to what could be a game changer for sufferers of this disease.
200 to 300 million people will become infected with malaria, and around 70 to 90 million will actually die from malaria every year.
Malaria is a female mosquito-borne disease that puts parasites into red blood cells. What Griffith University is trying to do is interrupt the life cycle of that parasite, interfering with its sexually reproductive stage, known as a gametocyte.
The problem with malaria is that you keep getting this cycle is evolving again and again, and it's because when the mosquito bites you, it's taking out parasites, there's another life cycle in the mosquito.
Some drugs are effective against the early stages when gametocytes are developing, but as they mature, the drugs don't work. Researchers at Griffith University have been awarded a $300,000 grant to help find compounds that do work. In this laboratory, unique to Australia, state-of-the-art equipment is getting through hundreds of thousands of compound samples every week. The malaria parasite is an ancient organism with a complicated life cycle that's had millions of years to evolve. Researchers are trying to find a compound to kill the gametocytes.
As technologies advance, as our knowledge about the parasite increases, then we have the opportunity to find better targets which to direct our drugs against. And then I think we can also find different classes of drugs.
It's time-consuming